All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations based on the Mozilla Developer Network Learn Web Development series. I am currently in the JavaScript section, and we are talking about client-side storage. We started to go through an IndexedDB example last time. We set the database up and we said this is how we're going to have to put in our data. So it says, let's now look at how we can add records to the database. This will be done using the form on our page. Below the previous event handler, but still inside of the onload, add the following line. This line, as it says, will set up an onSubmit handler that runs that's called add data, which will be written down below when the form is submitted. In other words, when the submit button is pressed, leading to a successful form submission. Again, remember, everything that we're doing in here, we're doing it inside of this onload function. So where is that? Right here. So looking at that, that says to me, well, let me do two things here. I put that in, but I'm going to take this line of code that's right, or this, I'm going to remove that, and I'm going to tab, 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 and let's put this way down here someplace. All right, there we go. All right, now let's define our add data function. So add this below your previous line. All right, so they say there it's quite complex, so they're going to break it down after they add all the code. So let me first put the code in there. It's about 30 lines or so. Tab that over, save. All right, so let's do it as I've done this kind of before. So I'm going to make this smaller and then go through it here. So it says this is quite complex. In breaking it down, run the prevent default on the event object to stop the form actually submitting in the conventional manner. It says this would cause a page refresh and spoil the experience. All right, so that's this line here. Next, create an object representing a record to be entered into the database, populate it with values from the form inputs. Note we don't have to explicitly include the ID. It's auto-populated, and that was one of the things that we had put in earlier. All right, so this is going to be our record. All right, and it looks as though at least we're not checking to make sure there is something put in there. I could be wrong on that. We'll check as we go on here. All right. Open a read-write transaction against the notes_os object using the IDB database.transaction method right here. This allows us to access the object store so we can do something, in this case, add a new record. Access the object store using the IDB transaction.objectStore method to save the result in the object store variable. Add the new record to the database using the IDB objectStore.add. All right, this creates the request object. Then clear the form afterwards. So it, as it says, so if we want to add in another record, add a bunch of event handlers to the request and the transaction to run code at critical points in the life cycle. Once the request has succeeded, we clear the form inputs. And that was here. Once the transaction is completed, we run the display data again to update the display of the notes on the page. And if there was an error, we put that in there as well. All right, next. We've referenced the display data twice in our code already, so we'd better define it. All right, add this to your code below the previous function. So we'll do the same thing, and you'll notice this is quite long. So I'm going to do the same thing I just did. So this code in here will break down, all right, after we put it in here. And we'll look at it up here. And again, okay, put a little space in there, so I'm on 86. This is about 50 lines long. All right, so let's get back there. There's where we were. I lost my f in function. I don't know how. I did not lose my f in function. But I'm going to try to move everything over. Again, hit enter a few times here. Give me some space and move this back up to here. There we are. There's our display data. So first we empty out the UL elements content. All right, before filling it with the updated content. If you don't do this, you'd end up with a huge list of duplicated content being added to each update. So we want to put each item in individually. And if we didn't do this, if we put in 3 items, we'd have the first item, and the second item would have the first item plus the second item, and the third item would have the first item plus the second item plus the third item, etc. Next, we get a reference to the notes OS object using this DB transaction. Except here it says we're chaining it together on one line. All right. The next step is to use an open, is to get basically to be able to go in and use a cursor. A cursor is a way that you can iterate over a database. All right. So in other words, it allows you to peruse your way through the records in the database. We chain an onSuccess handler to this to make the code more concise. Next, we get a reference to the cursor itself, which is right here. Next, we check to see if the cursor contains a record from the data store. Is there something in it? If so, we create a DOM fragment, populate it with the data from the record, and insert it into the page. So in other words, we've got a new record that we want to put in. So we're telling it to put it into our data store or our database. We also include a delete button. So that when clicked, it will delete, all right, the item. So notice equals delete item, which we may or may not, I think we haven't written that yet. At the end of the if block, we use the cursor continue to advance the cursor to the next record and run the content of the if block again. All right, if there is another record to iterate to, it causes it to be inserted into the page, etc. When there are no more records, it will return undefined. So basically this is going to come in and display all of our notes. So it's going to iterate its way through, and each time it goes through, if there's another note, it's going to add it to that list. All right, so that brings us up to here, where we want to talk about deleting a note. As stated above, when a note's delete button is pressed, the note is deleted. This is achieved by the delete item function, which looks like this. All right. So, it says the first part of this could use some explaining. We retrieve the ID of the record to be deleted using this. All right. So in other words, we want to make sure we're deleting the right record. Imagine that we had 2 Jeff Scotts who both worked in the IT department at Rankin in our record structure we looked at before. Now, one could work here in Wentzville, and one could work in, for example, in St. Louis. And before you laugh and say, "Oh, that had ever happened," when I first got employed about 5 years ago at Rankin, and I went in to the St. Louis campus for one of our orientations, I got tapped on the shoulder and I turned around. The guy said, "Are you Jeff Scott?" I said, "Yes." And he said, "Hi, I'm Jeff Scott." He worked in the electronics area, but I'm Jeffrey P. Scott. He was Jeffrey R. Scott, but we were constantly getting each other's mail. So the point of this is that you want to make sure you're always deleting the right record. So you should typically you would query the database, which means look through it to make sure you find the right one, but you want to query it based on ID number, not just in this case based on name. All right. We then get a reference to the object store using the same pattern we used previously and use the delete method to delete the record from the database. All right, passing it the ID. So we're telling it to basically remove the child right here. When the database is complete, we delete the nodes, list item, and then do it again. And well, one thing we want to do is if it's empty, there are no nodes stored. So we're just going to let them know that. All right, it says if you're having trouble with it, feel free to check it against our live example or see the source code. I like, again, trying to at least attempt to build this ourselves so we can see what's going on. All right, so what do we have left? Not a whole lot. I think before we go into this service, the offline asset storage and the service example, we'll see if we can get this part done because we're at 11.5 minutes, so we're doing okay time-wise. All right. As mentioned above, IndexedDB can be used to store more than simple text strings. You can store about anything you want. So imagine, for example, that, and not using their example, but imagine that when you first come into Rankin, you get your picture taken, and we do for our badges. But let's say that they wanted to store your picture along with your other information about you in the database. That'd be something like that, a video or in that case, an image that you could put in. So it says to demonstrate this, we've written another example called IndexedDB Video Store. When you first run the example, it downloads all the videos from the network, stores them in an indexed DB database, then displays the videos in the unordered list. The second time you run it, it finds the videos, gets them from there instead of displaying them, which makes it much quicker. It says, let's walk through the most interesting parts of this example. We won't look at it all because it's similar to what we looked at before. So we'll grab it here. So there it is. So you can see the examples that they've got. All right. And if I right mouse click on here and choose view page source, well, that's that, but I would actually probably want the index file. Okay, so let's kind of go with that. And well, how am I going to do this? I'll grab this, copy it, and for now, even though I'm probably not going to save it, let's put that in here. And we will just go ahead and take a look at it. Okay, not based off of here, but based off of here. There we go. All right, so looking at this, you'll notice as it says, it's again well commented. For we stored the names of the videos to fetch in an array of objects. That's what they're trying to get across to you, that we've got an array here. How do we know this is an array? Because the bracket here says start the array and end the array. And these are the name value pairs, all right, for each thing that's in there. Okay? All right, to start with, once the database is successfully opened with an init function, which is here, we loop through the different video names trying to load a record identified by each name into the video's database. If it's found, and we find it by checking that request, okay, it'll be true. And if it's not present, it'll be false. We also bring up its video files, and the video names pass straight to the display video function. All right, so that's pretty much what's going on here. All right, it says the following snippet is taken from the fetch video from network, which is right here. From here, we fetch MP4 and WebM versions. Remember, we talked about this before when we talked about some of the audio and video stuff. The fact is that typically you'll download at least a couple of these because not all browsers will have the ability to correctly look at every type of video. And typically, if you do two, like an MP4 and a WebM, you're probably going to be pretty safe. Although you very well might want to have some fallback content in there. It says we do have a problem though. These two requests are both asynchronous, and we only want to display and store the video when both promises have been fulfilled. However, this will work because we can do a promise all in here, which says run this as a transaction. So if both promises have worked, then do this. All right. So it says the all promise fulfills within an array containing the individual fulfillment values. Inside the all block, you can see that we call the display video function, and we also call the store video function to store these inside of the database. So the store video function, as it says, is similar to what we've looked at similar. We open a read-write transaction to get a reference to the video OS and then add it. Finally, we've got the display video, which creates the DOM elements needed to insert the video into our user interface and then appends them to the page. They mention here the most interesting parts of this are those shown below. To actually display the video, we need to create object URLs using the URL.createObject method. Once this is done, we can set the object URLs to be the value of our source element in here. All right. Says the above example already shows you how to create an app that will store large assets in an IndexedDB database, avoiding the need to download them more than once. This is already a great improvement to the user experience, but there is still one thing missing. The main HTML, CSS, and JavaScript files still need to be downloaded every time the site is accessed, meaning that it won't work without a network connection. You'll see something like this. As mentioned, this is where service workers come in, and I'm going to make that the last part of this lecture.